All right, now we're going to come to trig functions. So our last lesson where it was 30, 60, 90 or 45, 45, 90 triangles. Unfortunately, every triangle is not going to be 30, 60, 90 or 45, 45, 90. So we have to be able to account for all the other angle measures. And we do that using trig functions, which are sine, cosine, and tangent. Now, as I get to the front page in my notes here, sine, cosine, and tangent is probably something you've seen before, but you may not really understand what it is. What trig functions allow us to do, though, is it allows us to find sides and angles of right triangles. So while we're going to use trig functions later on for non-right triangles, for right now, we're just going to be dealing with right triangles and how to use our trig functions. So the first thing I did is I put a right triangle down here, triangle ABC, and if you notice, this is very important that the side opposite the angle is the same letter lowercase. So we try and be consistent with that. So capital A for this angle, the side opposite that angle is lowercase a. Angle B, the side opposite angle B is lowercase b. And angle C, the side opposite angle C is a lowercase c. Now why that is important is this. If you notice in sine, cosine, and tangent, you see the words opposite and adjacent quite often. Well, we have to determine what the opposite and adjacent sides are. And that's really just based off of what angle we're working with. So in angle A, our opposite side is A. And our adjacent side, the side next to it, is B. What's always consistent is the hypotenuse. The hypotenuse is always the hypotenuse. But opposite and adjacent change based on what angle we're talking about. So in capital A, this angle A here, the side across from it is the opposite side, and the side next to it is the adjacent side. When I come to angle B, the opposite side is B, and then the side A is the adjacent side. So it's important to understand each leg of the right triangle is opposite with dealing with one angle and adjacent with dealing with another angle. So it's important to understand which angle we are talking about. Now the thing that needs to be memorized is based on this saying called SOHCAHTOA. I don't love it, but a lot of people do, so that's why I present it. But basically, sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So what that essentially means is, if we look down here, the sine of A is opposite over hypotenuse, A over C. The cosine of A is adjacent over hypotenuse, which is B over C, and the tangent of A is opposite over adjacent, which is A over B. If I look at angle B, the sine of angle B is opposite over hypotenuse, B over C. The cosine of angle B is adjacent over hypotenuse, which is A over C. And then the tangent of angle B is opposite over adjacent, which is B over A. And that's where these ratios are down there. And essentially, all trig functions are is a ratio. Okay. Now, what we're going to do is we're going to try and use these ratios to figure something out. So what I did was I put the most basic right triangle we have, the 3, 4, 5 right triangle. And if I were going to try and find the sine of B, or excuse me, the sine of A, the sine of A is just opposite over adjacent. So the sine of A is 3/5. The cosine of A is 4/5. Adjacent over hypotenuse, and the tangent of A is 3/4. Opposite over adjacent. Now these angle measures here, if you notice, they're the same angle measures each time, because let's be honest, angle A is not going to change. And we can find the angle measure using any of these trig functions. The key to it is knowing how to work your calculator. So it's important that you fiddle around, play with your calculator, understand how it works. When we're finding an angle measure, we need to use the second function than sine, cosine, tangent. That's why I have these little negative ones right here. We call it inverse sine, inverse cosine, inverse tangent. And the reason we do that is it allows us to take our ratio and translate that into an angle. It's why our calculator is so valuable here. You could actually Google trig tables and kind of find similar information, but this allows us to find our angles much quicker and much more efficiently. And that's essentially why we're doing trig functions. It allows us to find angle measures. It's also going to allow us to find sides later on, but we'll get to that in the next lesson. In angle B, the sine of my angle B is opposite over hypotenuse, 4/5. The cosine of my angle B is adjacent over hypotenuse, 3 over 5. And the tangent of my angle B is 4 over 3, which is 4/3. And that would give us this angle measure here. Now, I know someone's going to ask, well, if we know that we have a right angle, and we have angle A, can't we just subtract from 90 to get angle B? You can, but for our purposes here, we're practicing the trig function. That's why I write the trig function out. Also, the other common question is, do we take sine, cosine, or tangent of C? We never take the sine, cosine, or tangent of the right angle. We just don't do that. So you just take sine, cosine, tangent of the two non-right angles, angle A and angle B. Now, why do we do this? Well, this allows us to find information when we're given limited information. You can ask, why do we have to know sine, cosine, and tangent, all of them, when all of them give the same answer? And the reason why is this. On a test, you're not going to be given 3 sides. You're going to be given 2. Now, you could say, well, I can use Pythagorean theorem and get that third side, and you'd be right, but that third side is probably going to be an estimated decimal. This allows us to work with exact numbers. So when I'm given from angle A, opposite and adjacent side, I use tangent. For angle B, opposite over adjacent, I'm still going to use tangent. So to find the measure of angle A, we use the tangent of A equals 7/5, and then we do inverse tangent 7/5. Inverse tangent 5/7. When I'm given side 6 and hypotenuse 11, and I'm using angle A, that means I'm going to use cosine, adjacent over hypotenuse. When I'm going to try and find the measure of angle B, I'm going to use sine, opposite over hypotenuse. And then the final one is when we have angle A here and we're given the opposite side and the hypotenuse from angle A. Sine of angle A is 8 over 13, and the cosine of angle B is 8 over 13. And the work is down here. And this right here is the only work you need to show. Literally what we're going to do is we're going to write down what we're typing into our calculator. And we can check our work as well. If you remember from chapter 5, the bigger angle, like in angle A here is 54 and angle B here is 35, bigger angle is always opposite bigger side. Smaller angle is always opposite smaller side. And we can use Pythagorean theorem here to get the third side and kind of check our work if we want to. The key to doing this successfully is understanding how to use your calculator and making sure you make a good decision. You have to choose the correct trig function to get the correct answer. Good luck, and good luck with the assignment. We'll move on to finding the measure of a side later on in the week.